A block moves across a table by a force pulling on it. Draw the free body diagram of the block if the table is frictionless, and if the table and block create friction. So let's go ahead and identify some of the relevant concepts we're going to be using. Now on this one, we're just going to be using Newton's second law, F equals ma. But we don't actually need to do any calculations. We just need to label the forces. So what we need to do is place forces. And the important thing to note here is we're only going to draw the forces that are acting on the object. We're not going to draw any forces that the object is applying to other objects within the scenario. And the other thing to note is our target diagrams that we're going to be drawing is there are two situations. And those are going to be with friction and no friction. So let's go ahead and set those up. Now since we're actually not going to be executing any variables that we're plugging in or solving for any sort of math really, we're going to do the setup and the execute all in the same step. So all we need to do is draw our diagrams. So for the first scenario, we're going to model our object here. We'll go ahead and divide this for our two scenarios. And those are going to be no friction and friction here. So this blue object here and here is going to be representing the block. Now for both of these cases, we have the weight that is going to be pulling down on it. So we can go ahead and label those in both situations. We can label that with AW. Now, since the block is not moving down, it's staying on top of the table, there has to be a reaction force according to Newton's third law. So we also have a force pushing up, and we'll call this the normal force. And this is going to be opposite and equal in magnitude of the weight of the block itself. Now after that, we also have a force pulling it towards the right. And since this looks like a rope, we're going to go ahead and indicate this with a T for tension. So we have something pulling it towards the right. So we do have a rightward direction of motion. While for the first situation, we have no friction, so it's going to go ahead and slide along regularly. For the second situation, we have friction, and what friction is going to be doing is going to be impeding the motion towards the right. So it's going to be slowing it down a little bit. So we can go ahead and draw a force towards the left, and we can label that F sub F for force of friction. And now we're done with our diagrams. All the forces are indicated. Now we can go ahead and continue looking at these diagrams here and just make sure that everything checks out. If we have no friction here, we're going to assume that the object is going to be moving a lot faster since there's no force impeding it and pulling it towards the left. And from our experience, we know that if there is some friction, that's going to impede our motion. So you can see here we have a force pulling it towards the left, and that's going to be slowing it down a little bit. So these diagrams here check out.